Welcome, everyone. So today our topic is the question, what is Passivhaus? To explain to you a little bit the background, what Passivhaus is, what makes it worthwhile doing, what makes it so exciting. At least for me, I'm always excited talking about Passivhaus. And this is something that we're doing in 3 parts. Today is Unit 1, and Unit 2 and 3 are coming always in a fortnight time. So if you want to catch that, join us again in the next 2 fortnights. We will sort of doing Units 2 and 3. If you can't wait or don't want to wait or find this really interesting after today, then these courses are also available on our website for a small fee. I will show you after the presentation where you can purchase that. Otherwise, yeah, they're always for free here on our little lunchtime talks. But yeah, let's not make so many words. Let's start on the topic so that you can see what Passivhaus is all about. As I said, we're talking today about what is Passivhaus design, giving you a little glimpse into why we want to do Passivhaus, what gets me so excited and other people so excited about this. So the first thing I want to do is I want to show you the agenda for what is Passivhaus design. So in our Unit 1, which is today, I'll give you first a little introduction, and then I will tell you why buildings are so impactful. In our Unit 2, which is in a fortnight time, we will then talk about the Passivhaus standard. So I'll talk to you a little bit more in depth of what the Passivhaus standard is all about and give you an introduction into the 5 Passivhaus components. And in our Unit 3, we are talking about Passivhaus design from a perspective of where do we start our design when we are a Passivhaus designer and what stops us from doing this. Why is not everyone doing Passivhaus? But because you will hopefully see that Passivhaus makes so much sense. And then we're asking that question, what are the things that are stopping us from doing this? Then we'll have a little conclusion. And as I said, today is Unit 1. Unit 2 and 3 you can catch for free in our lunchtime sessions, or you can get them on our website for a small fee. Introduction. So if you have seen some of our courses before, so if you have been part of Smart Plus Academy, maybe you have seen these slides, these next 2 slides before, but I think they're so important that I want to repeat them again. Okay. And this is Passivhaus for you in 30 seconds. So what is Passivhaus doing? So Passivhaus is creating healthy, sustainable, and affordable buildings. And while the outdoor environment is consistently changing, the indoor environment stays constant at 20 to 25 degrees. How is Passivhaus doing this? Passivhaus is creating a high-performance building envelope. It supplies us with fresh air 24/7, and it uses the free energy harvesting and heat recovery. Okay, so this is our Passivhaus in a nutshell. As I said, we are mentioning this a lot, but I think this is a great little one to recite when you're talking to your friends, your colleagues, anyone who's interested in Passivhaus, to explain to them in a nutshell what Passivhaus is all about. Obviously, we can go deeper into each of those components, which we will do. Also in Unit 2, we start talking about the components of Passivhaus to understand more how Passivhaus is doing that. But for a little summary, I think this is a really great start. Now I want to talk about why buildings are so impactful. Okay, so I believe that to understand why Passivhaus makes so much sense, we need to know what buildings are doing and what we can do with a good building to work against these problems that we are creating with buildings. Let me give you a little introduction here. So why are buildings so impactful? So we start from a health and comfort perspective. So in a building, we spend average of 90% of our time indoors. Yeah, that is 21.5 hours. Usually we spend quite a substantial amount of time in our bedroom for sleeping, around 8 hours, then work 8 hours. Other like watching TV, cooking, eating is often an indoor activity as well. So I sometimes thought, maybe this is not true for me. I'm an outdoor person. I love going outdoors. But if I see that I have to spend 2.5 hours each day outside to achieve those 10% outdoors, then I would say maybe this is actually true for me, because 2.5 hours outside every day is probably a good amount for me already. So for me, this is certainly true. And the problem is that the indoor environment is not our natural habitat, and that has a health impact. So we've created something artificial, and if we're not looking after this properly and seeing how that has an impact on us, then we can create health risks. Now, the other thing is, which you probably know, we are all humans and we all have the need for thermal comfort. So first we talked here now about a healthy environment. Now we need to also talk about the comfort that we're in. Okay, so we have a need for thermal comfort and we need to maintain our body temperature of about 37 degrees, plus minus a little bit, but we're all similar. And this is not, the thermal comfort zone is similar for all humans, and that isn't dependent on if we live in a cold or in a warm climate. Yeah, that body core temperature is similar for everyone. And it is a little bit dependent on environmental factors like temperature, radiation, relative humidity. So that comfort is dependent on that, what environment we're in, and also personal factors such as clothing and activity. Yeah, so obviously if we have a lot of clothes on and we're very active, we need a lower outer temperature to be comfortable than if we are clothed lightly and we are maybe relaxing somewhere or working in a seated position. But all of this is not climate dependent. Yeah, so this is more personal dependent, not climate dependent. And that's why we're saying this works for all climate zones. Good. Now let's have a look in this health and comfort a bit deeper. So the indoor environment should not give any cause for health risks. Yeah, so we shouldn't have any air pollution in our buildings. We shouldn't have any mold risks. And on the other hand, the indoor environment must also be comfortable. Why is comfort such a big thing? Why am I talking so much about comfort? Because when we're not comfortable, our body needs to adapt to the outdoor environment, and adaptation is always causing stress. And it's an additional work for the body. So we're sweating, we're shivering. While we can do that easily when we're fit and young, we might have a bit more problems if we are older, if we are really young babies. We are not so easily adaptable, and that can actually then cause a problem. Okay. So we have feelings and sensations that tells us if we are comfortable, and then we can adapt hopefully well and with not too much stress. So comfort means that our body is not under stress, it's at rest, so everything is okay. That's what our body tells us. And that's why comfort is health. Yeah, so we're always thinking of comfort as a little bit of a luxury, but no, really it's health related, because first something is comfortable, then it becomes uncomfortable, then it can become even unhealthy or a health risk, then a health threat, and in the end it can kill us. Sounds a bit extreme, but if you're thinking about those heat waves that we had in Europe a couple of years ago, where people that weren't well, that were a bit frail, they really suffered under this, and some of them didn't make it through that heat wave. There were lots of death related to heat. There are some related to cold. So all the extremes, if we can't adapt anymore, then it becomes really dangerous. So comfort is not a luxury, it's a health requirement. What do we do to work against that? So we want no health risks. And in a passive house, we have a thermal comfort zone with a temperature range between 20 and 25 degrees. Okay, so that's the beauty of passive house. We also want a relative humidity range between 30 and 60%. And that can make sure that we are comfortable in our home. And that's guaranteed with passive house. Studies have shown that about 92 to 95% of people are comfortable in this temperature and humidity range. So passive house really makes buildings comfortable. On top of that, passive house has some other requirements as well. So the relative humidity between 30 and 60% means that's our air relative humidity. But we also want to have relative humidity levels on at any point in the building below 80%. Because that reduces the risk of mold growth. Why am I talking now here about any point? Is because we have a relative humidity level for our air. But if we have cold spots or cold surfaces, so points in the building where there's maybe a thermal bridge, then our relative humidity can rise, because cold air, or when the hot air cools down, the relative humidity rises. Yeah, that's physics behind it that we will go into deeper also in our course, but that's how it is. And then the relative humidity can rise. And then at that point, we could have mold growth happening. And that's something we don't want, and something we can avoid with passive house. The other thing for comfort is that we want to have a surface temperature to the operational temperature, the difference not bigger than 4.2 Kelvin. If I talk about Kelvin here, it's another way to express a temperature difference. Okay, so it's the same. 4.2 Kelvin is similar to 4.2 degrees Celsius, but usually when I talk about a difference, I talk in Kelvin. When I talk about an absolute temperature, like 20 degrees inside, then I talk about degrees. Yeah, so also a little bit of physics. So 4.2 Kelvin, we want to have the maximum difference between surface and air. Why is that? Because that limits the risk of drafts. You've probably all sat to a single glazed window in winter when it's cold outside and you felt this really uncomfortable draft, the cold shoulder effect on you. And that's because our temperature difference is too big and then we're feeling a draft. And this 4.2 Kelvin limits that risk of drafts. For our floor to the air temperature, we want even less because we are in direct contact with the floor. So we only want 3 Kelvin difference there. Then the air temperature difference at 1 meter height difference. So if you're sitting in your chair, we want less than 2 Kelvin difference so that we don't get that hot head, cold feet effect, which we have in conventional buildings often. So this is all about our comfort range in our indoor environment. Now, for our indoor air quality, we also want no health risks, and that's also something that a passive house makes sure that we have. So again, our thermal comfort zone, the same again, 20 to 25 degrees, 30 to 60% relative humidity. It's probably we're repeating that so you can really remember that it's crucial for a passive house. But what we also want is a sufficient design airflow rate. And this sufficient design airflow rate makes sure that our carbon dioxide, CO2 levels stay below 1,000 parts per million. That is considered a healthy indoor air quality. And that's what we can do with our mechanical ventilation system. That's what we can achieve in a passive house. On top of that, we're using filters for our units, for our mechanical ventilation units, to take all the contaminants out, like the pollen, the dust, everything that comes from the outside is staying outside. And that makes sure that the air that's coming in is clean and fresh. And especially people who have suffered with respiratory diseases, asthma, and so on, they can really feel a relief in a passive house. There's other filters as well to protect the mechanical ventilation unit so that everything stays hygienic as well. So that was now on our health and comfort part. Now let's move on to why our buildings are so impactful from a sustainability point of view. Okay, so that's the second part, why buildings are impactful. And here's our beautiful planet Earth, and it's our only home. We haven't found a planet B yet, and we and life as we know it need a climate as we know it. So that's something that we found out. And humans always had a massive impact on nature. Yeah, so we caused many extinctions, and at this time, at the moment, we are actually tampering with the climate, and we do that on a global level. And we all know that to preserve what we have at the moment, the beauty and the species and the variety, we need to stop climate change to make sure that we can sustain the life as we have it now. Now, I want to show you an example and what our contribution is to this climate change. But first, I want to show you another example that I found really eye-opening. Hopefully, you find that too. So every day, each person on Earth puts 0.5 kilo of trash in landfills. Yeah. And you know how many people there are on this world. It's like 8 billion people. And every one of us every day puts 0.5 kilo of trash in landfills. That's a massive number. But what is even more shocking is that every day, each person on Earth puts 15.5 kilos of CO2 into the atmosphere. That is even a bigger number. Yeah. And that's on average. Yeah. That's on average for every person in the world. That's 31 times the amount of trash that we put in a landfill. Now, to visualize that a little bit, I've put up here a little image for you. So on our impact every day. So I said to you before, 15.5 kilos of CO2 into the atmosphere. We have to put that into relation because that's equivalent to the natural CO2 present in 100,000 cubic meters of air, because we have a mixture of gases, obviously, in there. So this is what it's equivalent to, and I try to visualize that. So this lighter beige box cube is representing the 100,000 cubic meters of air, and this here is the size of a 2-story house. So this is how much air each person on Earth pollutes with CO2 every day. And if you live in a more developed country like Australia, you're most likely adding 1 to 2 times your own body weight of CO2 in the atmosphere every single day, because that 15.5 is obviously an average for every person in the world. So you're probably even more responsible for more. So that's why we need to see how we can reduce that. And we'll come to a conclusion that buildings will be a very good starting point in a minute. Now I want to show you again how our CO2 concentration in the world changed, because I've heard so many people saying, oh, CO2 has always been going up and down. It's nothing new. We've always sort of gone up and down. And that's true. Yeah. So natural levels have always gone up and down. So here we're showing the last 800,000 years. That's due to natural processes, volcano eruptions, all of these things, solar flares and things like that can change these things. But it has only wavered always between 100 and 300 parts per million of CO2. And always it has taken a bit of time to go up and down. Yeah. So nature had a bit of time to adapt. But we have now crossed the 400 parts per million line. So we've really done a big spike, and we're not stopping. So that last little bit that you can hardly see here, because it's such a short time span, we have really spiked here now with our CO2 levels. I've checked it the other day. Well, actually in August, I checked it, and there it was at 421 parts per million already. Yeah. So you can see now, while that is true, that nature does these things as well, we have now in such a short amount of time raised it so much that nature doesn't have the chance to adapt. And that's always when things become dangerous, and things can switch quicker than we can adapt as well. Now, this is obviously now all a general, what do we do to this earth? How do buildings have to do with that? Okay, I want to circle back to that now, why buildings are so impactful. And here we can see that in our global share of final emissions from 2017 are these numbers, we can see that buildings and the construction industry have a big share on those emissions, about 39%. That's more than a third comes from the building industry. And I find that such an eye-opener. We can do something, okay? We, all of us building professionals in this profession, we have now the chance to turn this around and do something good for our environment. So within this 39%, we obviously have our different sectors. We have the residential here in orange, our non-residential, and our construction industry. But we can really see that we have a big part to play in this. So 39% are directly related to the building and construction sector. And we are now the key player to secure a sustainable future. What we want to do is we want to reduce the energy consumption. That's the first step we want to do. And we make our buildings the power stations of the future. So there's this big chance for you. Now let's have a little bit of a closer look into the share of domestic fuel and power. So what happens in a home. So, and what happens here is, this was also a data from 2014, but I don't think it has changed much, that what is very clear to see here is that our space conditioning and our hot water heating is the biggest part of the energy that we're using in our homes. Okay, so space conditioning and water heating combined are responsible for 63% of our domestic fuel and power usage. Yeah, so only lighting, cooking, and appliances are compared to that rather small. Now, the good news is that Passivhaus can reduce this big part, and it can reduce the conditioning from 40% to 4%. So we can do a 90% saving on the conditioning, and domestic hot water from 23 to 9%. Yeah. So all up, Passivhaus can cut the domestic fuel and power into half. Yeah. And that's a 50% saving on our energy with Passivhaus. And I think that's massive. Okay. So we need to drastically reduce CO2 emissions to slow down climate change, as we said before, and Passivhaus can do a big part of that and can cut it in half. Now, this is something that I want to mention because I think it's a fantastic saying. The most sustainable energy is the one not used. So what we first want to do is we want to reduce our energy usage before we even thinking about producing renewable energy or storing it or something like that. First thing we want to do is we want to reduce our consumption. And then for the rest that we still have, then we can think about renewable or other alternatives. But the first thing we have to do is always reduce. Good. So that was on our sustainability side. Now we want to have a brief look at affordability. So on the money side of things, because that's also always a big question that people have. So for that, as a background, we have to say that buying or building a home is a major financial decision, and it's a biggest one-off investment for most people of a lifetime. It also has the biggest ongoing costs, where we have a mortgage, which is usually fixed, or, well, at the moment, interest rates are sort of fluctuating as well, but we also have the running costs here with a really high fluctuation, especially now where fuel prices are going through the roof. And that's why it's so important to consider the budget and the value of the investment and what we need to do. So what is Passivhaus giving us, okay, in terms of affordability? And we can say that Passivhaus is a low-risk financial investment. Why is that? Because we're investing into quality. And when we're investing into quality, that means that we're modeling our performance. So we know exactly the outcome already before we start building. And we're building then as we've modeled it, and we're getting it as we modeled it. So in the end, we have a financial control because we have got everything pre-planned and we know how much energy we're going to use for our building. We have financial control, so we have control over the construction cost. Obviously, that's something that we can always see beforehand. We get a quote and we know how much our building will cost. But to now, we had no control over we never have control over the energy prices. We don't know what they're going to do in the future. But energy efficiency gives us control, because if now our conditioning is only 10% of what we had before, then we're not so influenced by the rising and dropping prices that we have at the moment. Energy efficiency means that we're not burning our money for heating and cooling, and that we have no risk of fuel poverty. Fuel poverty is this thing where we can't pay our energy bills anymore, and that doesn't happen with Passivhaus so much. And we have comfort with a clear conscience. So all of that, what I've said before, we have our health, we have our comfort, we're doing something good for the environment, and in the end, we are less dependent on rising or falling energy prices. Passivhaus is also a low-risk humanitarian investment, so we get our improved health factors with our healthy indoor environment and indoor air quality. We have a higher security extreme temperatures. So now with climate change coming, we can expect more extreme weather events. And with Passivhaus, we're more protected. Yeah, we are making our indoor environment inert from the outdoor environment. So we're separating the two environments. And if there's any extreme things coming, we're more protected. And that works for the cold and the hot season both ways. Passivhaus is good for both seasons. And on top of that, we're reducing our ecological footprint. So we're gaining something. We're gaining health and comfort and security by doing something good for the environment. Good. And then we have to talk about short and long-term return on investments, because that's a thing that people are really thinking about. So we have an ideal investment into our retirement with Passivhaus, because after our mortgage is paid off, we have nearly no running costs. And wouldn't that be beautiful if you just live in your home comfortably and don't have to pay for it anymore? And we have a stable and healthy environment. Now, on top of that, we can gain up to 25% higher borrowing capacity. Now, this is now when we take incentives and green loans into consideration. We've got a separate course on that where Daniel explains how that works. So these days, there's a lot of options out there to make Passivhaus even more interesting. And then we even have to pay less for it because our interest rates are lowered, yeah, for energy efficient homes. And then we have made a comparison between a Passivhaus and a conventional home. And with your green loans, with your incentives, we could even have additional cash from day one. Yeah. So obviously, we're not financial advisors. You have to look into your own thing, but we want to make sure that you know that there are these things out there that can make Passivhaus really, really attractive from day one, and even more attractive than a conventional building. So does Passivhaus cost more? So Passivhaus can definitely be economical. So normally we would say without those incentives that Passivhaus, the additional costs are between 0 and 20%. Why do I give here a range? It's because we have to see what we're comparing it to. So if it's a low quality build, then it's more 20% additional costs. But if it's already a high-end build, then it's probably not much additional cost for bringing it to Passivhaus standard. The usual Passivhaus costs are about 200 to 750 per square meter additional, but with good planning and experience, the overall project cost should be achieved to the same costs. So we don't have to pay more. And what we have to say here is that Passivhaus is the lowest hanging fruit with the smallest green premium. It can even be negative in the long run. And now, hopefully you've got that overview why Passivhaus makes so much sense. Yeah, from a health and comfort, from a sustainability and from an affordability point of view. And that's the basis on why we want to do Passivhaus. And this is now the end of our Unit 1. Thank you very much for being part of this. Next time we will talk about the Passivhaus standard and the 5 Passivhaus components. Now, before we finish up, I want to tell you that if you enjoyed this, if you want to watch it again, you can either watch the replay on Facebook for our Unit 1, but if you can't wait, or if you don't want to wait for our Unit 2 and 3, you can get that on our website here on our courses. So you go to smartbusacademy.com, you select under all courses, more courses for designers. And in there, we have the benefits of Passivhaus design, which is also a nice course that we've run in the past few weeks. And then the one that we've talked about today, what is Passivhaus design, is here. You can purchase that and then watch Unit 2 and 3 immediately and at your own time. Otherwise, you can wait for us to come back in a fortnight where I will present Unit 2. Thank you, everyone, and hopefully I'll see you in a fortnight. Bye.